Okay, good morning. Am I audible?
Yes, sir.
Okay. So today, what we discuss is yesterday we understood the recursive function, and there is one more problem which can be solved by using the recursive function. You understood how to solve Fibonacci and how to solve um, what is that factorial and the GCD, and all these examples even you have understood in your lower semesters also. Okay, so now one more beautiful thing that can be solved by using the recursive technique is solving the problem of star of Honai. Okay, so what is star of Honai? Let me write here. So say for example so this is let me call it as peg. Okay. One second. Peg A, and similarly I'll take another peg so let me call this as B, and one more peg I'll take here. This is C. Okay, I'll call this peg as B and this peg as C. OP people are seeing? Can you people see the whiteboard?
Yes.
Okay, so now, so on peg A I have 3 disks. Let me take 3 disks. So you can take any number of disks. I'll restrict it only. This is disk 1. One disk is placed on this peg A. So I'll place another disk. And one more disk on top of this. Okay, I have 3 disks. So the bigger disk, and this next smaller disk is placed on the bigger disk, and the smaller disk is placed on the top. You know, it looks like a tower. Okay, so what is the problem of tower of Honai is, okay, you have to transfer all these disks which are there on peg A to peg C. This is my source peg. Okay, I got to transfer it to my destination peg C using only one peg, that is B. B is the auxiliary peg. Now using this peg I should go for transferring all the disks which are there on peg A to peg C using peg B as auxiliary peg. OP people understood?
Yes.
Is that clear? What do you have to do? Can anyone tell what you have to do?
You have to transfer the elements from peg A to peg C using
B as auxiliary. Okay, so you have to shift all these disks which are there in peg A to peg C using B as auxiliary. Okay, or you can say temporary peg. Now, but with 2 conditions. So what first condition is? So you can move only one disk at a time. How many disks you can move at a time? One disk. That is the first condition. And the second condition is that you cannot place a bigger disk on the smaller disk. Okay, so right now you can see all smaller disks are placed on the bigger disk. So the second condition says that when you're shifting the disk from one peg to the another peg, so you cannot, any point of time you cannot place the bigger disk on the smaller disk. Always the smaller must be on the bigger. Understood? You cannot place the bigger disk on the smaller disk. So these are the 2 conditions. So now taking into account these two conditions, you should go for shifting all the disks which are there on this peg A to peg C using B as auxiliary. So that is what our problem statement is. Okay, you can move only one disk at a time, and any point of time you should not go for placing a bigger disk on the smaller disk. Okay, so can anyone tell what I can do now? Yeah, what is that I have to do now to shift? So what is the first move I can do?
So place upper disk at C and the disk below it at B.
Okay,
And then
let us try. You keep telling, I'll do that. Okay, now you're saying place this upper disk on which peg?
C.
Okay, let me call this as 1. Let me number them. So this is 1. Let me number this as 2, and let me number this as 3. So you're saying move the disk 1 from A to
C.
Okay. Let me erase disk 1 from here. So disk 1 I've erased there, and you're saying move it to C. Okay, I'm moving it. 1. Okay, 1 is shifted here. I've made 1 move. I'll write here. The number of moves also I'll write here. 1 move. Okay. Next.
To shift to at B.
Shift 2 to B. Okay. I'll erase this. Here to B.
Yes, sir.
Two is shifted here, and I have made 2 moves. Okay. Okay. Next what?
Shift 1 to B.
Yeah, from A I have to shift back, the peg 1 to B. So now 3 I cannot move. So if I move 3, 3 will come on top of 2 or on top of 1. So that means you are placing the bigger one on the smaller one. So which is not allowed. So now I can go for placing this 1 on 2. Correct, right? Now
Yes.
in the next third move, I'll erase this, and now I'll move it on to this. Okay, what has to be done in fourth move?
Shift 3 to C.
3 to C. Okay, in the fourth move, see it says 3 is available. My intention was to transfer all the disks from A to C. Correct, right? A to C. Now this 3, what I'll do now, I'll erase from here and I'll shift it to C. Sorry. So that is move number 4. Yeah, next.
Shift 1 to A.
Shift 1 to A. See, I cannot place here. If I place here, that is not required. Correct, right? What I can do is, so this 1 can be shifted to A. A is available now. So I'll shift 1 to A. So 1 I'm shifting here. So that is the fifth move. In fifth move, so I move the disk number 1 from B to A. Next, what I'll do?
Shift 2 to C.
Disk 2 from peg B to C. Okay, I'll erase it from here, and then I'll two. Okay, now that is in the sixth move. Now in the seventh move, okay, so this 1 I'll directly move it from peg A to C. Okay, 7th move. Yeah. So now how many moves, total number of moves required to transfer all the 3 disks from peg A to peg C using B as auxiliary? 7 moves. In general, okay. So the number of moves required is equal to 2 to the power number of disks, number of disks minus 1. Okay. Now how many disks were there? 2 raised to 3. Number of disks for 3 minus 1. How much it is? How much it is? 2 raised to 3 is 8. 8 minus 1 is 7. So the total number of moves required for you to shift these 3 disks from peg A to peg C using B as auxiliary is 7 moves. OP people understood?
Yes, sir.
Okay. Say for example, if I have 4 disks, okay, how many moves you require? 2 raised to 4 minus 1. That is, totally 15 moves are required for you to transfer the 4 disks from peg A to peg C using B as auxiliary. Clear?
Yes, sir.
Okay. Now what we basically did here is, so let me go back to the original state. Now we have already shifted them. I'll erase all of them. Okay. Let me write here. So disk 1 and then disk 2 and then disk 3. So the step goes like this. So what you have to do is, so from the source peg you have to move the first n minus 1. Okay, how many disks are here? 3. So n value is 3. N is 3. I have 3 disks. You have to move n minus 1 disks from the source peg to auxiliary peg using the destination peg as temporary peg. So these n minus 1 is nothing but what here? This 3 and 2. So 3 and 2 must be moved to this peg B using C as auxiliary. Okay, and then shift this last peg directly to the destination and move again the n minus 1 disk which are there on the B to C using A as auxiliary. OP people are following? Yeah, let us do it again because I want to make this concept clear, n minus 1 concept. Okay, now come again. So where I'll be shifting this 3?
C.
To C. Okay, observe now. See this n minus 1 disk, what I am telling now. So I want them to be on B. Okay, I want them to be on B. This n minus 1 disks. Okay, so to shift this lower disk to the destination peg, I want this n minus 1 disks to be present on the peg B. So only when I make these n minus 1 disks to be present on B, so it is possible for you to shift this bigger disk to the destination. Yes or no? Yes or no?
Yes, sir.
For you to move this lower disk to the destination peg, so you have to move the first n minus 1 disk to what? B. That's the same logic we use even when you're writing the program. Okay, recursive function. Okay, observe now. So 3 get shifted here. Let me erase 3 here. The disk 3 get shifted to C. We are shifting it to C. And then what we do? This 2, where we shift it? Where we shift it?
B.
To B. Next what you do? 3 we shift it to B.
B.
Correct, no? So the n minus 1 disk which I mentioned here, using C as temporary, we shifted them to what? B. So then only, if you are able to move this n minus 1 disks from the source pack to the auxiliary pack using destination pack, so then it is possible for you to move the lower disk to the destination. Now this lower disk can be easily moved to C. Okay, so move the first n minus 1 disks from source peg to auxiliary peg using the destination peg as temporary. Okay, and then move the last disk, correct, one disk from the peg A to peg C. And next what you do, again you start shifting this n minus 1 disks, which are there on the B to A. Okay, B to A, and shift the last disk to C. Okay, so this shifting this n minus 1 disks, correct, no? For initially we shift n minus 1 disks from peg A to peg A to peg B using C as auxiliary, and then we shift the last disk to the destination, and then what we do, we move the remaining n minus 1 disks from B to A using C as auxiliary, and then the last disk again it gets shifted to this. Okay, this is how it works, and when I go to the algorithm I'll show you. So we make use of this concept. Okay, we make use of this concept n minus 1. Okay, it is clear? Yes?
Yes, sir.
Okay, so now
Yes.
okay, so what we will do is, so we'll try it for 4. So we did it for 3 in 7 moves. We'll try to do it for 4 now. Number of disks 4. We'll see how to do it. One, two, three, 4. Okay, yeah, what you have to do, you have to move this n minus 1 disks, correct, no? Only when you move this n minus 1 disks to B using C as auxiliary, then you can move this one disk, correct, no? The lower disk to C. Yeah, tell me now, tell me the moves. I'll erase the lower part also, this also. So totally 15 moves are required right now. Yeah, tell me what to do now. Yes,
4 to C.
4 to C. Okay, let me do that. So first move, so I'll write here first move from A to, say, disk 1, sorry, first move, let me write it little clear. So D4, disk 4, I'll write it as D4. D4 from what to what? A to C. Okay, this is move number disk 4. We are moving from A to C. Okay, I'll erase from here. I'll write here. Okay, what is it? 1. Okay, what is the next move? Sorry, 4. This is 4.
This 3 from A to B.
3 from
A to B.
A to B. Okay. So now in the second move, so I'm moving D3 from A to B. Okay, I'll erase this. I have 3 here. Next,
Disk 4 from C to B.
So disk 4 from C to B. See, 1 is bigger, okay, it is in this order. 1 is bigger, 2 is smaller, next again, next is 3 and next is 4. Now you are saying 4 to B. That means 4 is smaller disk than compared to 3, it can be placed on this. So in the third move, so you are moving D4. I think I've written wrong here. This is not D3. D4. It is D3, no?
Yes, sir.
Yeah. So D3 from A to B we have done. Now we are trying to shift this D4 from C to B. C to, this is C. Okay, C to B. Okay, we'll do that. So now this 4 here. Okay, next. See, n minus 1 I have to shift here. Yes or no? To B.
2 to
So
C.
2 to C. So in the next move. Okay, I don't know why this is. So it happens sometimes like this. Okay, so now in the fourth move you are moving D2 from A to C. Okay, I'll erase this from here. Now I'll shift it to this is 2 now. Yeah, what is the next move?
Sir, disk 4 from B to A.
Disk 4 from B to A. So in the fifth move, D4 from B to A. Okay, I'll erase this now. So D4 is placed here. And next one. What is the next possible move? Sixth move.
D3 from B to C.
So D3, sixth move. You're moving D3 from B to C. Okay. Three here. Okay. Next.
Sir, D4 from A to C.
D4 from
A to C.
A to C. In the seventh move, D4 from A to C. A to C. I'll erase this. Four. Okay. Next. What is the next
Sir,
move?
D1 from A to B.
D1 from A to B.
B.
In the eighth move. So D1 from A to B. Disk 1 is moved here. Okay, next. So this process should complete, when? So in 15 moves. The minimum moves required is 15. Yeah, what is the next move? See,
D4 to A.
yeah, this one, I should have here. Okay, D4 to, in the ninth move, D4 to A. Sorry, C to A. C to A. Smaller one it is. To A. Next.
Sir, D3 to from C to B.
So C to B. I'll not write the moves now. 3 here. Okay, I'll erase from here. Next. What next? See, we did it easily for 3, but 4 complicated. Huh?
Disk
Louder.
4 from A to B.
4
Disk
from
4 A to C.
A to B.
A to B. Okay. So 4 is smaller than 3. Okay, no problem. But someone count the moves.
Sir, but it will be a waste of steps.
Yeah,
But
wasting.
sir,
We are
A to
wasting.
C.
Sir, A to C is better, sir.
A to C. So you got to do it in minimum steps. How much? 15 only. A to
C, sir.
C.
which one? Disk 4.
Yes, sir.
Okay, next.
Disk 3 from A to no, B to A.
B to A. Next.
Then disk 4 from C to A.
C to A. Four. Okay. Now. So one should
Disk
be
2 from C to B.
2 from C to B.
Then disk 4 from A to C.
Okay. We'll just stop here. So I'll show you now. Okay. So you understood how to move it, with 2 conditions. Okay. I have the animation here. Okay. We'll go with this. So I think I have to reset it again. Okay, so we have I think 7 disks are there. Let us not take 7 disks, and pegs are also more. So we'll focus on only 3 pegs. So 3 pegs, and let me start with 3 disks first. Okay, so disk 1, disk 2, disk 3. So I have 3 disks. Okay, so now you can just count. I'll just say source solution, you can count the moves. So the total number of moves required already it has told 7 moves. Okay, just observe now. So disk 1, disk 2, disk 3.
Sir, I can only see whiteboard.
Oh, sorry, 1 second. I have to share my screen. Just a minute. So I'll stop this whiteboard now. I hope you people can see now.
Yes, sir.
Yeah, 1 second. I am refreshing it again. Okay, so I'll choose the number of disks to 3 and the number of pegs now it is 5. Okay, we'll not worry about 5 pegs, only 3 pegs are enough for us. Okay, so I'll just say get solution. See, it says shifting 3 disks from the source peg to the destination peg using 1 as the auxiliary will happen in 7 moves. Okay, for me now, so this is my destination peg, so I want to shift all of them here, so using this as the auxiliary. Okay, so animation they have taken this as the destination. Hope you understood. This is my source, this is my destination, and this is my auxiliary peg. Okay, using this auxiliary peg I want to shift all these disks from here to here. Okay, so just check the solution now. I am running it and keep counting the number of moves also. So the first disk is moved here, second move, third move, fourth move, fifth, sixth, now seventh. 7 moves it is done. Okay, now what we did, I'll again show the solution. See these 3 are here. Okay, so we move this n-1 disks using this as auxiliary, destination as auxiliary to this. The first n-1 will be moved here. Observe now. So I have the first n-1 disks moved from here to here. Now you can move the last disk here to the destination. Now again move the first n-1 disk from here to this. Okay, now transfer this disk to the destination and here. Okay, now so I want you to take a pen. Okay, so number this smaller disk as 1 or A, whatever, whichever is convenient to you. This as 2 and the bigger disk as 3. 1, 2, 3. Okay, so let us all follow the same thing. So 1, 2, 3. Number this smaller disk as 1. So take a piece of paper and a pen. So smaller disk, you name it as 1, and next disk you name it as 2, and the next disk you name it as 3. So take this as peg A, and this as peg B, and this as peg C. So call this first one as A peg, and this one as B peg, and this one as C peg. Okay, I want you to write the moves also. When the disks are getting moved, say for example first move, the disk 1 is getting moved from A to C. So that is what I want you to write. So now I'll increase it to, so number of disks to 4, and pegs again I just want it as 3 itself. Solution. See, it's saying how many moves? 15 moves. So it can be solved in 15 moves. Okay. Is that fine? Hello? Hello.
Sir.
Yeah. So now write this. Give number to this peg. The first one as 1. So next bigger one is 2, and call this as 3, and call this as 4. So call this peg as A, this peg as B, and this peg as C. Okay? Is it clear? And write the moves, because you'll get to know how the disks are moved from one peg to the another peg. Okay? So 15 steps you got to write now. I'm just running the solution now. See, first our intention is what? So to shift this disk from here to here, first I have to shift this n minus 1, these 3 disks from here to here. Okay, using this as auxiliary. That is what happens. Observe now. Move 1. This is the second move. Third move. Fourth move. Fifth move. Now this is the sixth move. Sixth. Seventh. See, in 7 moves I have this n minus 1 disk which I had here shifted here. Okay. Now 8th move is done. 9th move. 10th. 11th. 12th. 13th. 14th. 15th. In 15 moves they got shifted. Is it clear? Yes or no?
Yes, sir.
See, so I add 4 disks here. Now what the logic is something like this. First you got to move the first n minus 1 disks from the source to the auxiliary using destination as temporary peg. And the same process you got to repeat. Okay, and move the final disk from source to the destination, and then again move the first n minus 1 disk which are there on the auxiliary peg to the source peg using destination as temporary peg. So you got to recursively do the same thing. So you have this, you'll get this, and the same thing we are going to write a program, not for the graphical something like this, so we write it for, and it will show you the number of moves. Say for example, if you have 3 disks, so disk 1 from where to where it should be moved in the first step, in the second step from where to where it should be moved, like this. Okay, so this is an animated example. Okay, now let us take for 5 disks also. So for 5 disks you require 31 moves. So total number of moves required is 31. So get solution. See, this the first n minus 1 will be shifted here. Okay, just observe, keep observing. In 15 moves, this first n minus 1 will come here. See now, the first n minus 1 disk which were here, they got completely shifted here. Understood? Now finally the last disk we are shifting it to the destination. Now again n minus 1 from here you have to shift it to this, using this as auxiliary. Observe now, the last one we shift it here. So first 15 moves for shifting them here, now the next 7 moves for shifting them to the other one. Now place this one from here to here. Now you have the next bigger, so this one getting on top of this. Now again these two disks should be moved here. So this one shift here, this one again here. So now this can be shifted here. Again this n minus 1 disks here, n minus 1, that is the first disk, will come to this peg A. Now shift this last disk to the destination, and this one here again. Hope you understood?
Yes, sir.
Okay. Now the solution, in the form of algorithm, what I am showing you now. See, move top n minus 1 disks from the source peg A to source peg B using C as auxiliary peg. Okay, I have 3 pegs. So destination peg is C, no doubt. So but first what you have to do, you have to move the top n minus 1 disk from the source peg A to source peg B using C as auxiliary, and next transfer the remaining disk from peg A to peg C. Getting? So the remaining disk will be what? The bigger disk. So that disk you are transferring from the source stick, because you have the top n minus 1 disks moved to what? Peg B. So and you have only the bigger disk remaining in the peg A, that you shift it directly to what? Peg C, your destination. And then again move n minus 1 disks from, now where are the n minus 1 disks now present? They are on the peg B. The top n minus 1 disks which are on the peg B, you move it to peg C using A as auxiliary, and the same process should be repeatedly done, until all the disks are transferred from the source peg to the destination peg. So this is the simple logic, and how we do it? We do it recursively. Okay. So how? See here. And every recursive function, as I told in the last class, should have a termination condition. Correct, right? So this is how we call the function. So number of disks we are passing. We are passing the source peg, we are passing the auxiliary peg, we are passing the destination peg. So here n value is 3 for us. Well, let us assume we are using the number of disks 3. And what is our source peg? Hello? What is our source peg? Please respond.
Peg A.
A. What is our auxiliary peg?
C.
No, C is destination.
D.
B is
Peg B.
auxiliary peg, and C is destination. Okay. Now here we check. If n is equal to 1, okay, what is the solution? Move the disk 1 from source to destination and return directly. If there is only one disk, you can directly move it from what? Your source peg A to the destination peg C, that is, and end the structure. So if n is not 1, okay, move n minus 1 disks from source peg to auxiliary peg, okay, from A to B, using destination as temporary, or you can say auxiliary. So and then call again this is how we do it. Call tower n minus 1, move the n minus 1 disks from source to auxiliary. Observe here, this is my source. Move from source to auxiliary using destination as temporary. And next what you do, move the disk n from source to destination, okay, and then move the n minus 1 disk from the auxiliary peg. Now you have this n minus 1 disk present on the auxiliary peg to destination peg using the source peg as the temporary. So now how to do this? See, only the order will change. Move the remaining n minus 1 disks which are there on the auxiliary to destination using source as the temporary. Hope you understood.
Yes, sir.
Yes, sir.
So initially you have all the disks on the source. Yes or no? So you just try to understand the meaning of this. So initially you have all the disks on the source peg, that is A. Understood?
Yes, sir.
Now you just take n minus 1 disks, the top n minus 1 disk from the source, and you are shifting it where? To shifting it to auxiliary peg, that is B, using C as temporary. Okay, so the n minus 1 disks from the source, they get shifted to this auxiliary peg using destination as temporary. And once you do that, once you shift the n minus 1 disk from source to the auxiliary peg, so you have the last n disk, correct, no, nth disk, the last disk on the source peg, you can move it to the destination. Next what you do, so now after moving the nth disk, correct, no, from the source to the destination, the source peg will be empty. And where are the remaining n minus 1 disks? They are on the auxiliary. Now auxiliary becomes the source. Yes or no?
Yes, sir.
Auxiliary becomes the source. From this auxiliary, you move the n minus 1 disks to where? To destination using source as the temporary. And this process we repeatedly call. See, so again here call tower, and this is also call tower. Okay, so when the pegs, disks are on the source, you move the first n minus 1 to auxiliary, okay, using destination as temporary. So and then shift the last disk from n from source to the destination, and then you have the remaining n minus disk on the auxiliary. Okay, so shift this n minus 1 disks to the destination using source as the auxiliary, and repeat this process. Okay, so keep repeating until all the disks are shifted. How many? Say if it is 3 disks, 15 moves. If it is 4 disks, 31 moves. Okay, we keep repeating until n becomes how much? 1. So that is the termination condition. So I think so after this I have to discuss the program for this, and then so this function Ackermann function we'll discuss later after discussing the program for this. Okay, your next lab program is based on this. So next lab program, that is the lab program number 5, okay, is 2 things are there. One is evaluating a given postfix expression, and another is solving the tar of Honai problem, okay, for the given number of disks. So disks may be 3, 4 or 5. The program should say how the disk should move from one peg to the another peg. So we consider only 3 pegs here, okay, not more than 3. So hope you understood. Your 5th program has 2 things. So 5th program is 5A and 5B, something like this. Understood?
Yes, sir.
Okay. So this is very important here. See, the concept of n minus 1 is very important. So if I ask you a question, initially what is that you'll do? You'll move the first n minus 1 disk from source peg to where? Auxiliary using what? Destination as temporary.
Destination.
And next what you do? Move the last disk, correct, no, from source to the destination. And next what you do? Move the n minus 1 disks which are there on the auxiliary peg to destination using source as the temporary. So this is the logic. Same thing we apply even when we are writing the program. Okay. So I think we'll stop here for today. So tomorrow, so I'll go with the program of this star of Honai. Okay, and then you understand the program. We will also trace it. Okay, trace the program, and then after that we'll go with the next topic. Okay. And I think after this soon we will be getting into the queues. So after this Ackermann function, so yeah, we soon we are going to start one more data structure, queues, and if I complete queues, the module 2 will be done, and then we can get into the module 3, that is linked list. Okay, so we'll stop here, and we'll continue again tomorrow. Tomorrow is the lab tutorial class. In the lab tutorial class, I'll be explaining you. I think tomorrow it is not possible for me to complete the program of tar of Honai. I can complete the program of evaluating a given postfix expression. Tomorrow let me do that. So next week we will take up the program for tar of Honai. So but what I'll do is I'll just continue with a day after tomorrow I'll be continuing with this Ackermann function. So I'll complete this and I'll get into the queues. Any doubts if you have, you can discuss with me.
So the Hanoi problem, the program for it, and we will write the code for it. We'll be writing it using stacks, right?
So I'm not able to hear you properly. Can you speak louder a little bit?
So the program for Hanoi problem, the Hanoi tower problem,
Yeah.
that will be written using stacks, right?
Yes. Recursion. So it's basically implemented using recursive function.
Okay, fine.
And stack is also used for storing the return addresses. That I'll explain you when I'm debugging the program. So for all recursive call, stack is required.
Okay, sir.
Because the return address gets saved onto the stack, and that stack also plays a major role here. Okay, I'll explain when I debug the program. You'll understand. I think the tar of Honai program not this week. It will be next week. Because tomorrow I'll be giving you the program for converting the infix postfix, evaluating the postfix expression.
Okay, sir.
Okay. So and then thank you all. We'll stop here.